Well, let's be clear. I do care for you and I do care for your advices. I take them and I always try to improve myself and try to be as interesting as possible. But you can't always satisfy everybody. I also know that. And I stand behind what I said and I can explain to you if there are some unclarities. However, we are constantly bombarded with information from all around, and most of them are just irrelevant. They just come and go. We forget them because they're not important for life as a whole picture of it. And that's why most of it is a small talk. We just are created to talk and to communicate with one another. So for today's video, I would like to go a little more deeper into, last week we have a construct, now I would like to have a concept, and that is a concept of infinity, as you know it. You know, for example, that numbers go from minus infinity to 0 to plus infinity. And I will try also to connect religion with science, and I must say I respect both, all religion and science. And the premise of today's lecture, if you will, would be the quote from Einstein, and he said that two things are infinite, and that is the universe and the human stupidity. And I'm not sure about the universe. So if you think about the universe as a finite object, then you can always ask yourself, well, what is behind the borders then? Maybe another universe, or it can just go forever, if you know what I mean. And I think Einstein also asked himself these things. And he also asked himself about the time. What about the time? Is it finite or infinite? And science on one hand teaches us that it all began with the Big Bang. The universe exploded, and since then it is expanding. And on the other hand, religion says that at the beginning it was God, and God created all the things. But one thing you may not ask yourself is, well, who then created God in the first place? Or what caused the Big Bang in the first place? You see, you can always go further and further, and it's like it never ends. And that's today's thought. Infinity, like my videos, it seems they don't end. But one day, they will just go down and someone will replace me, as is always someone replaced by someone else, because evolution goes on, and that's how it is in this world. So now, the second part, I would like to go deeper into mathematics and explain to you how we calculate with infinity there. So this is what I want to show you today. It's nothing very difficult what we will look at. And the subject is the so-called Euler-Riemann zeta function, or just Riemann zeta function. And zeta is the Greek letter, and it's a function of x, and this is a sigma, capital Greek letter, which means a sum running from 1 to infinity, where n is 1 to infinity. And the function is 1 divided by n to the power of x. And you can see here is 1 divided by 1 to the power of x, plus 1 divided by 2 to the power of x, plus 1 divided by 3 to the power of x, and so on. You get the point. And while Euler explored the function for x is a real number, Riemann extended the problem to x is even a complex number. But we are going to look just at two results from Euler, who, by the way, wrote in his life more than 800 publications. That was in 18th century, I think. And he also proved that this is connected to prime numbers, but it exceeds today's lectures, if you call them like this. And first, we would like to look at harmonic series, which is a zeta function of x is 1. And it's just simply the sum of 1 divided by n, which is 1, you can see here, plus 1/2, plus 1/3, plus 1/4, and so on. And what Euler did is quite remarkably, he preserved all numbers 1, he preserved and all numbers which are the 1/2, 1/4 is the power of 2, and 1/8 is the power of 2, and 1/16, 1/32, 1/64, as you get the point. And all in middle powers, he replaced them with the nearest power of 2. So 1/3 he replaced by 1/4. And all of these, 1/5, 6, 7, he replaced with 1/8. 1/8, 1/8. And then what he did, he summed up those, and he summed up those. And you see 1/4 plus 1/4 is 1/2. And 1/8 plus 1/8 4 times is again 1/2. So you can see that if you sum up 1 plus all 1/2, you will get eventually infinity, of course. So this function, excuse me, is infinite, and you can see that this one is actually smaller than this, so if this is infinite, then this one must be infinite as well. And the next problem, also made by Euler, is a so-called Basel problem, where x is 2, and simply the series is 1 divided by n to the power of 2, or squared, if you will, which is 1 plus 1, 2 to the power of 2, plus 1 divided by 3 to the power of 2, and so on. And he remarkably showed, but it's much complicated to do it here, that this is actually pi squared over 6. And you can ask what pi is doing here. You know it from the circle for sure. So this means that the functions, if we would write the functions and starting from 1 and calculate the area, we will get here the infinite area, but here the area is finite. So even if the sum is infinite, its result is finite. And that's what I wanted to show you today. So thank you for listening. I hope it's not too much for you, but I thought this was it for today. You know, it looks like I'm doing a video every day. That means 365 videos through a year. And the subjects are different. So thank you.